For this lab in MSE, we are measuring the water contact angle to determine if a material is hydrophobic or hydrophilic. This lab was done by Alex, Andrew, Darshan, Juan, Manthavia, and Matthew. So some background for this lab is that we are finding materials that we think are hydrophobic and hydrophilic, and we prove this by looking at the contact angle of the water on the object and the angle that it takes for the water droplet to slide off the material. So we tested wood and plastic, and we measured their contact angles and roll-off angles to see if they were hydrophobic or hydrophilic. So in this diagram, we see what contact angle is needed for it to be classified as hydrophobic and hydrophilic. So we can see that if it's less than 90 degrees, then it's hydrophilic, and if it's greater than 90 degrees, then it's hydrophobic. And so in this lab, we used water droplets and we placed them on the surface using a dropper, and then we took images and analyzed them in ImageJ to find the contact angle. So this is the example of a hydrophilic material, and we used wood for this. And you see in the right section of this image that we have the angles of each test that we did. So for each test, you can see that the angle is less than 90 degrees, which means that it is hydrophilic, and also the mean is 38. So even if a few tests were bad or made us have a skewed data, we could still determine based on the mean that this material overall is hydrophilic. And another test is a sliding angle, which means the angle at which the object slides off at. So if the angle is pretty high, then it's going to be hydrophilic, but if the angle is very small, like 10 degrees or 20 degrees, then it's hydrophobic. So we see that the sliding angle for this is 62, 70, 66, so it's fairly high, and the mean is also 66. So we see that since it has a high sliding angle, the material is hydrophilic. Now for the hydrophobic material, we use a plastic, and so we see that the contact angle is greater than 90 degrees for most of the trial runs. For some of them, it's a bit lower than 90, but that can be due to experimental error. And so overall, but the mean is 94, which means that the material overall is hydrophobic. And we can see that it makes a nice bead shape when it's placed on the plastic. And another test for this is the sliding angle, and we see that the sliding angle is relatively low. It's closer to the 20s or 30s, and the mean is 30. So we see that since it has a low sliding angle, that the material overall is hydrophobic. And so the materials behave this way because water is a polar molecule, meaning it has a partial positive and negative charges due to the difference in electronegativity between hydrogen and oxygen. So this means that wood is hydrophilic because wood contains cellulose, which has many polar hydroxyl groups. These groups can form hydrogen bonds with water molecules. Because of this strong interaction, water spreads across the wood surface, producing a low contact angle. And then the plastic is hydrophobic because most plastics consist primarily of nonpolar hydrocarbon chains. Nonpolar surfaces do not interact strongly with polar water molecules. Because of this weak interaction, water prefers to stick to itself instead of the surface, forming round droplets with large contact angles. And so this is also similar to the sliding angle measurements because of its hydrophobicness, it sticks less to the plastic, so it has a tendency to slide off. While because it's hydrophilic, it tends to be absorbed in the material, so the angle for the water droplets to slide off will be much higher. And then the behavior is because on the hydrophilic material like wood, mostly sliding behavior due to strong adhesion and spreading of the droplet. So that's going to lead to a higher sliding angle. While for plastic, it rolls off because droplets remain rounded and detached more from the surface. And so the applications of this is that hydrophobic surfaces are used for waterproof coatings, self-cleaning surfaces, rain-resistant materials, while hydrophilic materials are used for absorbent materials, coatings that spread liquids evenly, and biomedical applications. So this is our end of the project that we did for the water contact angle. Thank you.